Good afternoon, everyone. Thank you for joining the exciting session on GAN, that is Generative Adversarial Network. Today, we will walk through GAN step by step from the start of this exact architecture you are not seeing here. So, we will walk through how this GAN work from initialization to the training. The pull and push game between generator and discriminator, the kind of data they generate, and the real world applications, and the variants and challenges with respect to GANs. So let's start with our initialization. So here in our initialization block, we prepared two players for the GANs framework. There is a generator network and there is a discriminator network. So the generator is nothing but the neural net that takes a random noise vector as an input and tries to output the data or tries to generate the data that resembles like a real world or real samples, such as realistic looking face or something like that. Initially, these images will be terrible blocks and noise, but eventually, over time, they will improve within the feedback. Okay. Then there is one more thing here that is called as discriminator architecture or discriminator network. So this is nothing but a binary classifier which will takes the input data and it will segregate. It will tell that whether it is a real data or the fake data and tries to predict whether it is a real from the data set itself or it has been generated from the generator, or we can also call it as synthetic data. These two networks have opposing roles or opposing goals. The generator wants to fool the discriminator and discriminators to catch discriminator. The role of discriminator is wants to catch the generator's fake images or synthetic images which is generated from the generator. So the game is between generator and discriminator. Generator will generate the synthetic images which will be resembling like a real world images. And discriminator's duty is to discriminate between the real world and the fake images or the fake data. So this setup is similar to that of counterfeit artist versus police officer. Okay. So here in the training loop, we are having once this both networks are initialized, once this trainer or once its generator and discriminator has been initialized, we entered into the training process. This is where the learning will occur. And here we are having a sample real world data also. So here in the sample real world data, we begin by randomly picking a batch of real data from the data sets. Say real human face images or whatever. Okay, some images we are having, which will be a realistic images. Okay, now once we'll get the real sample data, generate a noise vector from that. We then sample a noise vector from the standard noise or normal distribution. Okay, so this is when we will drive the generator to create more data. And generator will do what? Generator will produce a synthetic data. Continuously, it will produce a synthetic data from the noise vector. At first, the output will look like blurry. Okay, it will be a degraded images. Okay, it will not be exactly same images since we are giving a noise vector only. So the image generated will be noisy or it will not be very good images. But after learning, it will generate somehow good images or increasingly real-like images. Or discriminator will receive the data. After generator will generate the data, discriminator will then receive the data. Now, once the discriminator receives this data, the duty of discriminator is to distinguish between the real and the fake data. Whether this is a real world data or whether it is a generated data from the generator, which is a fake data. Okay. And whatever it has been generated, it will form what? It will form a loss. So there are discriminator losses. How this discriminator loss will generate? So we will compute how good or bad the discriminator's decision is by using a binary cross entropy loss function. If it misclassified fake data as real one, the loss will be very high or loss will be higher. Okay, when it is misclassified itself with the fake data as real one, or it has said that the generator's data, whatever the generator has generated, which is a fake data, it will say that no, it is a real data, the losses will be more. The discriminator losses will be or higher. So then what will happen? Then again we will update the discriminator weights. We then use gradient descent to update the discriminator's parameter, helping it improve at detecting the fake images. Then again we will calculate the loss function. Again this process will continuously go on. Again the generator. Now generator loss will do what? We will compute the generator loss. Its goal is to generate the data that fools the discriminator. If the discriminator is not fooled, the generator is penalized. Okay. If the discriminator has discriminated good results between the real and the failed data, then generator will have a penalty. Okay. So update the generator weights again. They have to again update the generator weights, and again the same process will follow. Which process? Again, the generator will generate the data which will similar to that of the real world data, and again the discriminator will discriminate. The same process will continuously go on. Okay, the process will continuously the same. Okay, so repeat the training steps until we will get eventually equilibrium is reached, wherein the discriminator cannot confidently tell that the fake from the real images. At that time, the sign that the generator is producing the high quality images or high quality output. Okay, so once this output phase is reached, once the generator generates a synthetic data, at this point, it has internalized the data distribution and can generate new samples that look like they are same like that of the real world data, and we can use that data for different purposes. We can use, like we can have for different applications like AI art, face generations, medical emerging cases, fashion designing. Likewise, we can use it for multiple use cases. And when it comes to challenges, and limitations for this, so despite their power, GANs comes with challenges like mode collapse. The generators start outputting the same kind of data over and over again. Then training instability. If the discriminator overpowers the generator, the system will fail to learn. And then there is no clear evaluation matrix is also there. Okay, so like it's hard to say that when the GAN is done, or continuously the process of generating the images and discriminator will continuously follow. Okay, so these are some of the challenges when it comes to GAN. And what are the types of GAN? So there are multiple types of GAN, guys. There is conditional GANs, wherein we will add some prompt or we will add some label to the training. Okay. Then there is a deep convolution GANs. Then there is child GANs. Okay. Most famous for generating the high resolution human faces. Okay. It allows all the specific styles like hair, smile, age, likewise. Then we are having cycle GANs, which is used for image to image classification or image to image translation without paired the example, like turning horse into the zebras or painting into the photos, likewise. Okay, so this is what today we have understood. We have understood about the GAN architecture, which will include two networks. First is our generator network and second is our discriminator network. There is some competition going on between generator and the discriminator. Generator will generate synthetic images, and discriminator's duty is to discriminate between the real world images versus the synthetic images or synthetic data. Then we have understood about the training process, what are the different training process, how, when we will stop this process. We have understood about the applications of this. We have understood about what are the different challenges. Okay. And then we have understood there are multiple variants of this GAN. Okay. So this is what we have understood up till now. Let's dive into our coding part. So here I have installed Torch Vision and Matplotlib library. So I have installed this particular library. After installing this library, I have used this data set. Okay. Now, here I have imported all the necessary libraries, and here in this GAN underscore images, here the folder will be generated. After once all the training will be done, this folder will be generated. Here, all the resolution images, all the real world images will be, or synthetic images will be generated. So this is our latent dimensions, which we are taking as 100. Learning rate we are taking as 0.0002. Batch size we are taking as 64. Epoch we are taking as 50. And image size we are taking as 28. Since we are using our MNIST images, MNIST dataset, which is a black and white colored images, which is of size 28 by 28 by 1. Since our color channel is 1, it is a black and white images. Okay, so we are initializing our model, and here we are taking this data set directly from our library. Okay, we are taking this data directly from our library, datasets.mnist, which is a publicly available data set. We are downloading this data set here. Once it will be downloaded, it will be available here. Okay, and then we are defining two classes now, two networks we are forming. So here we are defining this user-defined function for our generator. Okay, so this is our function for the generator, which will generate images, synthetic images it will be generating. And here you can see the latent dimensions we are taking. And here we are defining the user-defined function for the discriminator, which will discriminate between the real versus fake images. And this is our training loop, wherein the training will happen. And this is the training for the discriminator and training for the generator. You can see we have run some epochs here. We have run 200 patches, okay, of the epochs, and you can see here it is giving me discriminator losses as this much and generator losses as this much. And then after running this particular code, the generator will generate the synthetic images. Earlier, the quality of the images will be lesser. And after some epoch, it will run. It will try and learn the patterns within the images, so that from the noise vector, and it will start generating good quality of images, or real. It will be resembling. It will resemble the image which will be near to that of your original data or real world data. Okay. So this is what our generator and discriminator architecture is. It will take some time. That is why I haven't run the code, but you can run this particular code likewise. Okay. So these are our contact number. This is our contact details. This is our mail ID. You can anytime call us. If you want any inquiry regarding admissions or other thing, you can just call us. Apart from this, there is every week we are having our industry connect sessions. Okay, every week our CEO, Mr. Bharni Kumar Depru, he is conducting a industry connect people. He is connecting with the different domain people, and you can see here, you can see in our YouTube channel. If you want to subscribe to our YouTube channel, you can subscribe to our YouTube channel, which is 360DigiTMG, and you can press the bell icon here, so that every notification when it will be added, any videos will be added, it will be updated to you. Okay. Along with this, we are also having a placement success stories. Okay. Every week we are adding like 2 or 3 stories we are adding every week. So This is what our students are placed in different sectors, from freshers to data scientists, data analysts, likewise. And this is all our industry connect sessions which we are taking. Okay, so this is it from my side, friends. We will meet on next Monday with a new topic. Thank you for joining. Goodbye.